All right, here we go. Okay, so, all right, got my microphone going. I need to mix that a little better. There we go. All right. Well, today is going to be kind of fun for me because, well, first I got to get the audio levels right. Okay. Today's going to be really fun for me because I have been going crazy on these blueprints lately. Um, and I kind of just wanted to show like what I've been doing. I feel like I'm really learning how to kind of pull this stuff off. Um, so I kind of wanted to just show a little bit of what I've been doing lately, specifically about blueprints. I think as I go through, we'll see some of the other more exciting things. But I really just wanted to show kind of what the blueprints are doing. Because I don't consider myself a programmer at all. I don't think I'm a programmer. So being able to actually use some programming skills to make the ideas that I want to come out actually come out is really exciting to me. So I wanted to show some of it. Might as well. Okay, so the first thing that took a lot of effort um, was, well, I guess I'll start somewhere simple. These, I'm going to just give you the whole lay of the land. I wanted a way to be able to move in and out of different worlds. I really want to play with this idea of the conscious and the subconscious. And in order to do that, I realized I really needed two worlds. I needed very specifically different looks. And because I wanted to kind of have it interchangeable, I realized I was going to have to get into some variable and preference storing type of situations. So the first thing that kind of opened up this floodgate of ideas are these doors. So let's take a look at these doors. So these doors are essentially just a method for getting the player character to a different level, which is honestly is fairly simple, right? It's you could do it really easily with just this open level node. But then it becomes increasingly more difficult because basically all the variables that are stored on that player character are reset when you open a new level. So in order to store that stuff, there is the game instance. This was really exciting for me. So the game instance, basically, from what I understand, it's kind of like a siphon or a pathway that stores things temporarily. So in this case, I'm storing the door ID. And later, as I kind of progressed through what I needed to do, I needed to store this destination. And I'll show you why actually in a little bit. But initially it was just storing this door ID so that I could address different doors. So when you go to a different door, you can say which door it is and what the destination for that door is. And that's an editable one. That way, once I place it, I can change the variable of the destination. But so this door was really nice. And then of course right here, just basically making sure that it's the right actor that's colliding. That way if there's another, actor that collides, we're not triggering the level. And then this was just a really simple, just rotating the little book that's here. And so I guess let's look at this in action. So when we play this, we've got this character, and as we get closer and closer and closer, when we collide with this, we actually switch to a different level. And that was the goal. And so if we look here, there's this book again. I'm going to have to figure out how to change the actor. And I'll probably use the destination variable to change the mesh actor. But as we can see, that door is there again. And then we can run through this level. I'll show this level a little bit more in depth later on, but I kind of just wanted to show the blueprints. And then as we run through this level, we hit another door, boop, and then we go back to this level, and now we have this character again. So that was handling the doors, but it got really, really tricky for a second. And that was mostly because of, let me show you. So I'm using the ALS system, and because I wanted to have a lot of the enemies share a lot of the traits of the ALS system that I set up, I'm using one blueprint, and because the enemy is a different skeletal mesh, I needed to like figure out how to change that skeletal mesh. So let's go into the event graph. This is just carnage. There's got to be a better way to do it. I tried to do it with arrays, and I just could not figure out. I'm clearly not using arrays correctly, because I just couldn't get it to work. I was trying like for loops and all that stuff, and it just I need to brush up on how to use arrays better. But let's get to right here, right? So event begin play. Right when the game starts, I set looking direction just because I prefer that for this level. And then here's the trick right here. I check if this specific blueprint is controlled by the player. And this is because technically, if we look over here where there is an enemy, let's go over here real quick. There's this enemy. But as we can see currently, it is the Dawn character. But we need it to be the bad guy. I've been calling it the Katana bot. So there's the issue, right? How I want to be pulling from animations. And the reason for that actually is due to, let's go into this right here. So this script right here that's on the character itself, if we go in here and edit this, this is handling a lot of the reactions and the action inputs. So at this point, this script, or this, I don't know what the right word is, but basically this bit of code is handling the different action inputs. So when we go through this action input, we set this to the damage, and then we actually go into this function. And this function basically handles the animation on a switch into the overlay, and we'll see that. I'll demonstrate that. But what is specific about this and why I wanted to use the same script is also because I have the hit reactions. And as you can see now, I'm starting to branch, but initially there weren't these branches. It was just one reaction type. And in these different reaction types, we've got a whole array. And these are really cool. I think it's a structure. It's kind of like an array with an array. I'm still learning all the proper ways to describe it, but essentially you have the type of attack animation and its corresponding response. And that way, every type of different attack animation has a different type of hit response. and I wanted those to be linked. So I'm using the same blueprint, but because I want it to be a different character, I had to do some different type of stuff at runtime. So if we go into the event graph again, on begin play, I'm checking to see if it is controlled by a player, and then I switch the katanas. And this is because I wanted the bad guy to have the orange and the good guy to have the green. And then here, I'm using enumerators like crazy. There might be other ways to do it, but I really like enumerators. So if it goes this path, we set this variable to Dawn, the main character. And then if it goes this path, we set it to AI1. And the reason I'm doing that is because eventually there will be more and more enemies. So I'm basically setting myself up to be able to set an AI depending on other variables later on down the road. And then if you guys remember the last time when I was doing all this stuff with the armor, the issue is, since this is the same blueprint, if Dawn does the armor magic, it also shows up on the bad guy. So if it is not controlled by the player, then we destroy all those actors. And then there's some other sort of starting the hood, and then doing some initialize stuff. Save that. And to change the actual mesh type, I did it at the base, because it was the closest to the root of the actual character. So if we go into this base at runtime, this is when I'm using these. This is when I'm using enumerators like crazy. So we're casting to the game instance, and that's because I wanted to be able to change the character type depending on the level. But before I ran into that issue, I was splitting it depending on if it's controlled by the player, and we set the skeletal mesh, which is this component right here, which is inherited as well. So when we go here, that same thing right here, that skeletal mesh, is inherited by the base. So I just figured I would change it at the base. So if it's true, if it's controlled, then we set to the tactical Dawn, which is the black outfit. And if it's not, we set the skeletal mesh to the katana bot. And then we go through the initialize stuff. The problem with that is when I go into the different world, it overrides the game instance or game mode and automatically sets it to the tactical Dawn. So I was like, okay, well, that isn't working. And that's when I used the good old game instance. And so if we go back to the door, let's go back to this door. Where'd the door go? Huh? Oh, there it is. So when we open up this blueprint, this is where storing that destination helped. So I store that variable of destination in the game instance. And then that way, at runtime, at the base, I can check and see what the most recent destination is. So if the destination is Cold Forest, which is the sort of like conscious level, then that condition is true, and we go up to the tactical mesh. But if that destination is false, which that's why I'm using that enumerator, because it'll be any subconscious level, then we go to the character in the white dress. And so that all basically happened because I realized that I could store those variables in game instance between different type or different level switches, which was so huge and super helpful. Another thing that I figured out that was really exciting was the sort of method I came up with for animation notifies. So let's take a look at something. I think the audio should be okay, so we can kind of hear this. But when Dawn is running, there's like some breaths that are happening. And they're really low right now because they're not exactly where I want them to be. But the reason for that was I wanted to be able to address each of those different character types while still sharing animations, but being able to still do notifies. So if we go on to the animation, so we'll go into the animations and let's find like a walk. Okay. Oh, see, I need to add those. Well, this will be a perfect example. So when they're walking, oh, never mind, because I don't want the breaths on walks. I want it on like jogs. Okay, so where is a jog? Or I guess it's called run. Run forward. Okay, so right here, these local breaths. I tried so many different things. Oh my goodness. I tried to create animation notifies, but the problem is I couldn't get the values to update inside of the notify, and it was driving me nuts. So through looking through tutorials and all that stuff, I found out that when you do these local notifies that are just local to the skeleton, which is perfect because as we can see here, the Katana bot is sharing the same skeleton as all the other characters so far, which is perfect because then I can have these animation notifies happening at the skeletal level. So when I go into the animation blueprint, these local animations can be addressed through a custom event, which opened everything up because I couldn't figure out how to get updated information about the character state to the animation notifies when they're just like on the override event begin or the overwrite receive notify or whatever. And at that point, I could do what I've found is incredibly helpful, these event dispatchers. So on the breath in, when that local breath triggers, we send off this custom event, and then we call to this event dispatch. And then that's where I can bind the event dispatch to something that is keeping and updating the information about the character state. So in the character blueprint, I created just an audio graph because there's going to be more audio going on. So I just kind of created its own graph. That way, anytime I need to trigger audio, I can just send an event dispatch to this graph that handles all the audio. And then here we go. So we bind event breath in. And then on breath in, we can do all the calculations for the different states. So we've got a gate that's selecting between this sort of high breathing or this low breathing and high breathing. And it's selecting which cue to go depending on the gate. And this gate is walking, running, and sprinting. So when it's running, it's doing these low breaths. And when it's sprinting, it's doing these higher breaths. And those are going into the select that is running this character type. And as we saw earlier, this character type is the enumerator that I'm using for the different like character states. So if it's dawn, it uses this select, and if it's the AI1, it uses this audio. And then of course I'm doing like some little delays on it so it's not like so exactly rhythmic. And then just pulling the mesh from here just directly and saying, hey, play that sound at the location of the mesh. And then the same thing is happening on the breath out, where I'm selecting the gate, finding out if the character is running or sprinting. And then that's going into dawn as another select, finding the character type, and then running that delay and playing the sound again. And this is so incredibly useful because now I can do any of those local events just to the skeleton. So like, for instance, the next thing I'm going to do is like when the player gets hit, I can just do a local notify to the skeleton, a skeleton notify. And then in that, on the animation blueprint, I can just do another event dispatch and then bind that event dispatch to here inside the character blueprint, and then I can really easily determine whether or not it is the player, the controller, the player controller, or an AI. So that opened up the floodgates, and I'm just like, I'm so delighted because that took so much searching and tutorials and playing and fiddling around till it works. So that was really exciting. So I guess at that point, let's just kind of see some of these things in action. Oh, but first I want to remind everybody visually, if we go to where this bad guy is, it's still dawn. It's still that initial character. But at runtime, we said to switch that skeletal mesh if it's not controlled by the player. So if we hit play and everything loads, there'll eventually be a loading screen. We can go ahead and run over there. And this is that state thing that I was talking about where I can change the overlay. And those animations play depending on the switch for the actual state. So when we're in Katana, now we can do all these fighting animations. And there's responses. And we'll see that in a few seconds. There's responses specifically towards those fighting animations. So as we look now, that character, that character is now not Dawn. Yeah, so it's pretty fun actually. So maybe at this point too, I can talk a little bit about how I set up that AI, because oh my god, I made the AI like too strong, and I was like demoing and I was like, I'm dying too fast. I can't even like debug stuff. So I had to like tone it down, but that's what's really fun is the ability to get that AI to be like really difficult to beat is definitely available. So I'm not sure. I don't know how to set difficulty settings yet, but I would imagine I could change a lot of the parameters for difficulty in the AI. So it's just like really hard to beat. So there's a lot of tutorials on how to set up AI, so I don't really want to like do a tutorial because I'm still learning and I feel like a total noob. But I'll talk about some of the stuff that I'm doing that I did kind of understand. But a lot of this, again, is based on helpful tutorials. But essentially, what's happening here is this is the initial state. It's just chilling. It's just chilling until you get into a proximity, and then we so this is the state that it's in. It's just chilling. It's not really moving to any target points. It's not moving to anything right now because it's just chilling, but it waits and just keeps cycling until we break that. And when we break that, we move into sort of the next state. And we set the state now to katana. And we saw that with the little like flip down, how we like equipped. That's its own overlay state. So we have to change the overlay state to equipped. And we changed the state to sprinting. Initially it was walking and it just felt too easy. So now the AI is sprinting, and we're moving to the enemy, and we've basically set up the enemy as sort of a thing that we can pass through the blackboard. And then we do the attack, and these attacks are triggered by the action inputs. So I can do more and more different types of attacks. Right now it's just a couple that are just random. But we attack, and then after we attack, there is a sequence. And that sequence is getting a random location and then moving directly towards that random location, waiting for a short amount of time with a pretty large deviation considering the time. So it either is like not waiting at all or it's kind of waiting. And changing this really changes the ability to beat this character. The longer this wait is, the easier it is. And I initially didn't have waits, and it was just going, it was ruthless. It was ruthless. So I had to add in these waits literally just to like stop myself from not losing every time I'm trying to debug things. And then of course, we find another random location. The reason I did this, I added another move to random location because I didn't want it to be too easy to know what it was going to do. If it was just attack, random location, attack, random location, it was easy to just like follow the character where it goes. So then I added 2 different random locations. So once it waits, it moves to another random location that's a little bit smaller, right? So the radius here is 1,000, and then the radius here is 7,000 or 700. And I noticed too, like just in my own playing, when this happens, the movement can either be really far away or it can be just like a sidestep, because I made sure to, with the move, here, I should do that again because that's fun. Allowing strafing makes it like a little bit harder because it can move side to side rather than just directional. But so yeah, having this second one just makes it a little bit harder to read the AI. Just adding a few different random locations. And then of course, when it's done with that, it goes back to attack. So yeah, that's kind of the state machine for that AI. Yeah, and that's kind of where I'm at right now with the game. I've been doing a lot with that other subconscious realm too, so maybe we'll go explore that as well. So when we press play, kind of the idea for this is that in this subconscious realm is where you get the keys that allow you to have that magic to summon. Magic to summon the armor and stuff. So there's these little areas that you can explore. So there's like an area off to the side that you go down. And then there's an area in the opposite direction that instead of going down, of course, goes up. And that's kind of the idea, and playing with this idea of the subconscious, how you can get closer to the conscious in the subconscious, but you can also go much deeper into the subconscious. And both are very valuable when trying to sort of discover things about yourself. And then, of course, there's sort of this area that will be kind of where you collect all 3 things. And right now there's no logic saying that you can't go back. But essentially you won't be able to go back until you've collected all 3 things. And then once you've collected all 3 things, now that I know how to use the game instance, you'll be able to store those variables. So once you actually have those variables available, you can do this summon thing. And that's basically kind of where where I'm at so far. Wanted to show a little bit of the code that I'm playing around with. And I guess I'll just keep playing. I've been recording this whole process. I do these live things just because they're kind of fun. But later on down the road, I'm going to put together some videos that are a little bit more edited of all the stuff that I've been doing to show the progress. But I figured today would be a fun one to just show some of the code that I'm playing around with and learning, because I am quite a noob. So I guess with that said, see you later.